one last page of the lesson. The next video is going to skip forward a couple of pages because we're starting lesson 2 in that video. Next one coming up, page 786. Let's put it all together. Talk the talk. We are going to talk about the counting principle, so last chance for some highlighter. And we're going to talk about the number of possible outcomes, so that's another highlighter space, in a sample space. And calculations vary depending on the situation. So some probability words popping up in that first sentence. Effie and Areti are describing scenarios of the possible sample space of 4, then 3, then 2, which makes 24 different combinations. And Effie wants to produce a scenario that has independent events and disjoint sets. So vocabulary comes in, highlight, independent event and disjoint set. Areti wants a scenario including one set with dependent events. And by the way, set is also one of the vocab words from this lesson. Based on Effie's description, write an example scenario involving 3 disjoint sets. So vocabulary word. And 24 outcomes in the sample space. Every vocabulary word in this last lesson needs to be highlighted just to call attention to it. Well, I'm saying this. Effie could be describing toppings and flavor options for Froyo. 4 different yogurt flavor choices, 3 toppings, 2 Corner Cup options. Of course, that's my scenario. Maybe if you disagree and have a different scenario of 4 choices and then something completely unrelated, right? Independent and disjoint means the answer choices here are not the same or even closely remotely overlapping to the answer choices in the next decision of the decision tree. And then last of all, your third choice is totally unrelated as well. Okay, well, with that in mind, right? With that in mind, we have 24 different arrangements that Effie could choose Froyo. B, based on Areti's description, write an example scenario involving one set with 3 events and 24 outcomes in a sample space. And I don't know where my brain went with this one. They could be arranging their kittens in order of favorite to least favorite, and they're just not going to like include their 4 kittens. They're not going to include the least favorite one in terms of, I don't know. So they're arranging them. They have 4, then 3, then 2. It's the place value of who could be the favorite, and then who, after you pick they pick their favorite, who is the next favorite, and then who is the like third, and then we just leave the 4th one as sorry. You just bite too much. Okay. But there's still 24 different ways that set of 4 things could be dependent and produce 24 different permutations. Okay, now last, we're going to finish with question 2 and then question 3. Question 2, it says, describe how to calculate the number of outcomes in a sample space of situations involving independent or dependent events. I could use the counting principle. Right, the counting principle means that you multiply your options and then the next level's options, and then the next level's options, and every time that you have a new decision or an action to choose from, to analyze, that you are multiplying by the number of possible scenarios that could happen at that level. And when you're done, you have the total number of outcomes. Calculate. List advantages and disadvantages to using a tree diagram. The main one with the tree diagram is it just takes up space. But you're able to trace the path of all of your decisions that could be made and kind of like decision like path out what would happen if and when and how they all might be interconnected. Like I could say B gives us triangle, gives us 1. Interesting. Yeah, B gives us triangle, gives us 1, whatever those represent. Oh, but what if we considered A gives us circle, gives us number 2? Okay, so then we have definitely like this ability to compare the decisions that are made from one choice to the next to the next. Do we like wind up at a decision down here and we like how it compares to a decision over here? Or are they just like, no, that was a bad one, this is the better path? It's really good for path finding the best decision for producing the outcome that we want. They take up space, but they are really good at helping path find. Organized lists do not take up as much space, but they are awful at helping pathfind because stuff gets lost in the list. We like the visual of the tree diagram to follow the visual of what's available. Organized lists, they keep track of everything nicely, but you can't trace your path so quickly or so efficiently to know what outcomes you want compared to other outcomes. That's what a tree diagram really does. Thank you for watching this video. Oh, sorry, catch it on the screen. Bump it up. There we go. Organized lists take up less space. You don't need all of the branches. You just make a list of bulleted like amounts. And you can kind of follow the pattern, or make a pattern when one exists. But it's really difficult to say, yep, I know there, then there, then there, and I have my decision made. You have to go through every list and every category of options. Thanks for watching this video, liking, commenting, and subscribing. This episode is done as it is. Lesson 2 is next up, so please thank you so much for paying attention to this one. Click forward on that one and keep learning, keep talking about probabilities. And heads up, in the next lesson, we're talking about compound probability using the word and in the problem. So we'll see you then. See you in the next episode. Thank you so much, and have a good one.